8M7, lesson 11, the decimal expansion of some irrational numbers. Today we're going to learn to calculate square roots without the square root button on our calculator, basically just approximating the square root, because as we have learned before, or maybe I've mentioned before, the square root of any non-perfect square number is irrational, which means it goes on forever and never repeats. So you can never get a perfect number for any square root of a non-perfect square. So we're going to see a little bit of that today, and let's get on with our lesson where we see more. All right, so we have two goals today. So we're going to learn to approximate square roots. We're going to learn a method for that. 80%, 90% of your homework is going to be learning to approximate square roots. And then we're going to recall our rules for irrational and irrational numbers. There's about 10 to 20%. This is going to be about 80% of your homework. And then this is about 20% of your homework. It's going to be involved in that rule. Now, with those rules. Now, building blocks. We've done this before as well. So let's recall that because the square root of 25 is 5, which means what times what is 25? That's what you're asking when you talk about a square root. You know, 5 times 5 equals 25. So the square root of 25 equals 5. What times what equals 25? Well, the square root of 36 is 6 because 6 times 6 equals 36. So if I ask you, you know, what is the square root of 30? What is the square root of 30? Well, I know that the square root of 30 must be between 5 and 6, because 5 times 5 is 25, and then 6 times 6 is 36. So somewhere in between, we have a box that has 30, and so this is like 5 point something times 5 point something is a box that's between one that's 25 and 36, right? This is our geometric version of squaring, right? So how big on a side does a box have to be to make an area of 25, 36, or 30? And then, or if you just want to think about it numerically, without geometry, you're asking what times what is 30, and it must be between 5 and 6, because 5 times 5 is too small and 6 times 6 is too big, so maybe 5.5, 5.4. Well, let's figure out the method for getting a better approximation. So what we're going to do is we're going to estimate here the square root of 5 in this problem. We'll do it in orange. Square root of 5 by finding the bounding decimal values to the nearest hundredth. So we're not just going to say that this is between two integers. We're going to get between two decimal numbers with two decimal places out. And the way we're going to estimate it is we're just going to find the bounding integers, and then we're going to find the bounding tenths by squaring and testing. And I'll show you what this squaring and testing method is in a second. And then we're going to find the bounding hundredths by squaring and testing again. And then we're going to keep going until we're within the desired interval. Well, in this case, we need the nearest hundredth. So we're just going to go integer, tenths, then hundredths, and then we'll be done. There's an example that we'll do in a little bit where we go to the nearest thousandth. So we'll just do the process one extra time. Okay, so let's find estimate number 1. Estimate number 1 should be easy for you, because the square root of 5 has to be between the square root of 4 and the square root of 9, right? So we know that it's between 2 and 3. So we know that the square root of 5 is between 2 and 3. Now what we're going to do is we're going to start in estimate number 2. Estimate number 2, we're going to get to the nearest, this will go to the nearest tenth. So now we want to figure out, is it between, is it between 2.0 and 2.1, or 2.1 and 2.2, 2.3? So the way that we're going to do this is we're just going to use a calculator, and we're going to start multiplying numbers until we find which one it's less than and which one it's greater than. We got to find two bounding intervals. Okay, so let's start at 2.0. We know that's 4. Now we're going to try 2.1. And the way we're going to do 2.1 is we're just going to go to our calculator and multiply 2.1 times 2.1, and that's 4.41. So we're going to keep going up until we're bigger than 5. Because 2.1 times 2.1 is 4.41. So let's try 2.2. 4.84, we're still not there. So 2.2 squared, so this is 2.1 squared, 2.2 squared, 2.3 squared. Let's see what happens with 2.3 times 2.3. 5.29. So we know that 2.2 squared equals 4.84. And we know that 2.3 squared is equal to 5.29. So the square root of 5 is between here and here. So now I can say, well, we can get more exact. Not only is the square root of 5 between 2 and 3, but the square root of 5 is between 2.2 and 2.3. All right, so that's our better approximation. Now, but we have to go one more. So now we're going to say, well, estimate number 3 is the nearest 100. So we can go now between 2.21. Well, let's go between 2.2, 0, 2.21, 2.22, 2.23, 2.24, 2.25, 2.26, 2.27, 2.28, and 2.29. Now, I'm going to do an optimization. I'm not going to start here and just keep going up. I'm going to kind of start, what should I do? I'm going to start in the middle. Because then if I'm too big, I can go down. And if I'm too small, I can go up. And then I won't have to run through 10 different times. So watch what happens. We're going to start with 2.25. 2.25 times 2.25 equals 5.0625. 5.0625. 5.0625. Now we're too big here. So we're going to try this one. Let's try 2.24. 2.24 times 2.24 equals, still too big, 5.0176. 5.0176. So 2.24 squared is still bigger than 5. So we got to do one more. Let's try 2.23 squared. 2.23 times 2.23. Well, there's 4.9729. 4.9729. So now we have our two bounding numbers again. So the square root of 5 is between 2.23 and 2.24. So 2.23 is less than the square root of 5, which is less than 2.24. So we have our bounding numbers to the nearest hundredth, because we know that this is, 4 point, that squared is 4.4729. That squared is 5, because the square root of anything squared is itself, which is less than 5.0176. So hopefully this makes some sense to you. Let's keep going. Let's use this same process, and we're just going to call this homework help. So we're going to find the square root of 11 to the nearest thousandth. Okay, well, we know, and then we're going to find the square root of 1649 to the nearest hundredth. Again, homework help. So I want you can pause and try using our prior numbers, so prior methodology. So the square root of 11, we know is between the square root of 9 and the square root of 16. So the square root of 11 is between 3 and 4. So I'm not going to jump over to the calculator. I'm going to just tell you what I see on the calculator as we do these calculations. Okay. So now I've assumed you've paused and you've tried, and the answer to, I'm just going to give you the flat out answer to these. First of all, the answer to this one is between 3.316 and 3.317. The answer to this one is the square root of 1649 is between 40, and this is only to the hundredths, 40.60 and 40.61. Okay, there's your answers. But let's go ahead and do it. So the square root of 11 is between 3 and 4. So I'm going to try, estimate number 1. Let's try 3.5. So 3.5. 12.25. So that's too big. So we'll try 3.4. That's 11.56. So we're still too high. So let's try 3.3. And that's 10.89. So we know that the square root of 11 is between 3.3 and 3.4. So now let's try number 2. So now we're going to try 3.3 to 3.4. So let's try 3.35. 3.35 squared. So 11.2225, too big. So we'll go down to 3.34. 11.1556. So we'll keep going down. 3.33. 11.0889. 3.32. 11 getting closer. 224. 3.31. There we go. Now we're below 10.9561. So we know that 3.31 is less than the square root of 11, but the square root of 3.32 is bigger. So here's our second approximation, but we want it to the nearest 1,000th. This is only to the nearest hundredth, so we have to go one more time. And so now we have to try all the numbers 3.31, and we'll start in the middle at 5. 3.315 squared. That's equal to 10.989 some, etc. That's too small, so we need to go bigger to find the upper bound. Let's see if 3.316 squared. Nope, that's 10.99 ... So let's go to 3.317 squared. 0.317 squared. And we get 11.002489. So we know that the square root of 11 is bigger than this and smaller than this. So we can write our final answer, 3.316 is between the square root of 11 is between 3.316 and 3.317, because 3.316 squared is lower than 11, and 3.317 squared is greater than 11. So we can write it like this. We know that that squared is less than 11, and 3.317 squared is greater than 11. Okay. So over here, we don't know what our bounding, so now let's go on to this problem. We don't know what our bounding integers are for 1649. So let's just take a guess. I'm going to guess 40, because 40 squared is 1600. So let's see what 41 squared is. That might be just on our other side. Yeah, that's equal to 1681. So we know that the square root of 1649 is between 40 and 41. So now let's try, so that's our first estimate, but we need to get to the hundredths. So let's try 40.5 squared equals, that equals 1640.25, too low. 40.6 squared equals 1648.36, still too low. So 40.7 squared equals 1656.49. So we know that we're between 40.6 less than the square root of 1649, which is less than 40.7. We know we're between 40.6 and 40.7. So let's try 40.65 squared. That's equal to 1652 ... So we're going to go lower because we're too high. 16.64 squared . 1651 points ... 40.63 3 squared is 1650 ... 40.62 is equal to 40.62 squared. 1649, still too high, 0.98 ... 40.61 equals, are we going to get down low enough? No, we're still too high. 49.17 ... So 40.6, we know that 40.6 from up here, 40.60 is 0.36. So we found our two bounding numbers. So there we have our answer. 40.60 is less than the square root of 1649, which is less than 40.61. So we're between 40.60 and 40.61. So hopefully you figured out the guess and test method for iterating and calculating estimates for square roots of non-perfect squares. Now realize that all of these numbers are irrational. So I could keep going forever and ever and ever and ever and keep getting the nearest hundredth, thousandth, 10,000th, 100,000th, millionth place, and I will never get a repeating number. These numbers will never repeat because they're irrational. That's something that haven't not proved to you. There's no proof for this so far in any of these lessons, but you can know that it is true and it has been proved. And maybe later on in these lessons, we'll go about proving it, but it's not required so far. Okay, now I'm just going to ask you a random question. 7/4 is rational. How do we know? And this is on your homework, so pay attention. 7/4 is rational, and that's because it is represented as a fraction with an integer in numerator and in denominator. Right? This is an integer and this is an integer. So by definition, so this is by definition rational. Okay, so next, 7. So now, is this rational? If this is if I have a number divided by a number that's rational, if I square it, is it rational? What do you think? Well, the answer is it must be. Must be, because 7/4 squared is equal to, by our exponent rules, is equal to 7 squared over 4 squared, which is equal to 49/16. And so again, by definition, I have a numerator and a denominator that are integers. So yes, it is rational. Now I'm going to ask you a question, and don't go about trying to calculate it. Is 7/4 to the 50th power, is that rational? What do you think? Well, the answer is yes, because each time you multiply 7 times 7 times 7, 50 times, that is an integer, Because an integer, because an integer times an integer equals an integer. So if I multiply this 50 times, it's equal to an integer. And this is 4 times 4 times 4 times 4. That's going to be equal to an integer, 50, and if I do that 50 times. Okay, so remember this for your homework. And now finally, I want to give you some rules. And this is the rules this is a summary. This is just a summary. We've learned all of this in module 7. So decimals, there's 3 types of decimals. If a number terminates, it's rational. Here's some terminating decimals. 4, 6.5, 9.1234, 5. These are all terminating decimals. So these are rational. Now, if a number doesn't terminate but it repeats, it is rational. So, right? So numbers like 4.3 repeating, 1.1616 repeating, 9.012492, all of that repeating. These are rational. So that means these can all be represented as fractions. And that's, you can even find that fraction using lesson 10. This was lesson 10. Showed us how to convert these repeating decimals into fractions. Now, the only type of decimal that isn't rational is one that doesn't terminate and never repeats. So like 4.9124231784 ... never repeating. Never repeat. So that's going to be an irrational number. So either a number terminates, and in which case it's rational, or if it doesn't terminate, you have to figure out whether it repeats. And if it repeats, it's rational. If it doesn't repeat, then it's irrational. Okay. For fractions, if a number can be written as a fraction a over b, where they're integers, a and b are integers, it's rational. So like 9 over 11, 1 over 2, 4 over 968. Now, sometimes you can write numbers as fractions that are still irrational, like the square root of 3 over 2, that is irrational. That's irrational because this is not an integer. Not an integer. So this doesn't count. But all of these, because the top and bottom are integers, these are rational. Okay. Well, that's the fraction rule. The square root rule is if the radicand is a perfect square, the number is rational. So this is like the square root of 9, the square root of 100, the square root of 144. These are all perfect squares because square root of 9 is 3, square root of 100 is 10, the square root of 144 is 12. But if these are not perfect squares, if the radicand does not have a perfect square, then it's irrational. So the square root of 3 is irrational. The square root of 2 is irrational. The square root of 99 is irrational. The square root of 1602 is irrational. These are all irrational numbers. Okay, so those are our rules. Let's lay down a happy cat. Did some good work today. And we'll be moving on to lesson 11 tomorrow. Lesson 12. We're going to move on to lesson 12 tomorrow. So hopefully this was good. Hopefully it was a useful lesson for you. Leave me feedback on YouTube, like the channel, leave a comment for a question. A number of students have asked me questions. I'm happy to answer those. And we will be, again, back tomorrow. Happy math, happy cat.